computer. Okay, so let's go ahead and do this schematic capture of the 7805 using the KiCad software. Um, I'm going to open up KiCad in just a minute, but we're going to be making use of this spreadsheet quite a bit. This is our bill of materials. And so you'll find this on the Canvas, a link for this spreadsheet on the Canvas site. It's the ECE 304 bill of materials for the 7805 project. And so now I want you to picture the schematic in your head here, and I'll walk you through it. So the center of it is the 7805 voltage regulator that takes our input greater than 5, and it's going to produce an output of 5. On either side of that is a capacitor. There's a 0.22 microfarad capacitor on the input and a zero point 0.1 microfarad capacitor on the output. We also have an LED on the output. At both the input and the output, we're going to have some header pins where we can bring our wires in from the outside. We also have test points, and we have a switch. We have an LED and a resistor. And so all of those components are listed here. Here we have the 7805, and then we have the capacitors, the headers for bringing the input voltage and taking the output voltage, our LED, our current limiting resistor, our test points, and then our switch. Now, all of these are components that have their symbols and then the footprints for the symbols in KiCad, with the exception of the switch. And uh, uh, we had to create a special set of symbols, both the schematic symbol and the footprint symbol for the switch. And Colin Del Senor created those, and they're contained at this Google Drive. And so we're going to have to upload those onto our KiCad project in a bit. Um, Okay, we're going to go up and do two things with KiCad. First, we're going to create our schematic, and that's going to make use of all the symbols that are shown here, schematic symbols. And then once we have that wired up, we'll go and we're going to start up a new video where we're making the PCB, and we're going to make use of these footprints. So I'm just going to leave this table here in the background so we can refer to it as we're picking symbols. And if you haven't used KiCad before, and I appreciate that many of you haven't, then it'll become clear what I mean in just a minute when I talk about symbols. Okay, I'm down the bottom here in my menu bar. I'm going to click on and open up KiCad, and there it is. I'm using the latest version of KiCad, version 8, and let's see what if I can actually get the actual version that I'm using, 8.0, 8.08. So it's a fairly new build. Last year we used KiCad 7. This year's number 8. I think there are some quirks in it that are still coming out, but I've mostly been able to do what I need to do without difficulty with version 8.0.8. Okay, so we're going to start out up at the top on the file menu, and we're going to create a new project. Now, I keep all of my KiCad projects I have a sort of a top directory called KiCad, then uh, 8.0, that's the actual KiCad program itself. I also have some data sheets. There's been a fair bit of bloat as I've been using KiCad over the years and have different versions, and I store all that stuff in junk. I don't think I'll need it, but I keep all my projects here in a file called projects. And I have last year, 2024. I have other courses and other projects where I'm using KiCad. For this course, I'm going to keep everything I need in a folder called 2025 ECE 304 projects. So I'm going to go to that folder. Okay, and now I'm going to create a new project here, and I'm just going to call this 7805 demo. Okay, so it's going to create a new folder for us in this directory, and KiCad opens up, and it just has 3 files here. They'll all be blank. The KiCad.pro is sort of the parent file here, or the project file. KiCad.pcb will be the printed circuit board, which we're going to do in the next video. And then SCH is the schematic capture, and that's where we are right now. So double click. Double click. All right. and we're in the schematic capture mode. Um, Now, I find it necessary to use a mouse when doing this. Maybe you're more adept at using a trackpad, but you'll sort of figure out what's best for you. So the very first thing is I do want to go and put some documentation down at the bottom. I find there's really nothing more useless than a piece of work that doesn't have any documentation for you to refer to. So I open this up. Um, okay, issue date, I can just click on this and the date will show up. This is going to be revision 0. Well, I'll call it 1. I'll call it version 1.0. And this is the 7805 um, demo for ECE 304 2025. Okay, company is UMass Amherst, ECE. This is just Dave McLaughlin. So let's see if I have enough there. I mean, I end up with this sort of proliferation of files when I build things, and it's nice to have some documentation. So at least I'll be able to know this is the first version of a demo that I'm making for you all. Okay, that's all done down the bottom. And now we're going to start picking and placing components. And so this is where it's going to be helpful to go back and pull up this document. Let's see, I'm going to hide this. I have this other document here. And let's see, what I'm going to be doing here is just working through these symbols. We have the 7805, a couple capacitors, some connectors, an LED, a resistor. And you'll notice that for some of them, the symbol is very obvious. C for capacitor, LED, R for resistor. Um, but let's get the first one, the LM7805 TO220. So this symbol over here that looks like I guess it looks like an op amp. I'm going to click on that. Okay, sometimes it comes up and it tells me that there's an error loading a particular file. Some of these are things we don't care about. Some of these are things that we will care about, but I'll show you how to deal with it. Okay, so so I wanted 7805. Just typing that in, and it's the LM7805 TO220. And we saw that in the spreadsheet. I'll go back and show it to you, but I'm just going to say okay, and I'm going to drop it right here. All right. Um, and again, back to the spreadsheet. That was our 7805 TO220. Okay, now I'm going to grab a couple capacitors, LED, and resistor. I'll grab the sort of the easy things first. Easy in the sense that their symbols are obvious. Okay, a couple of capacitors. Just going to type C, and we see unpolarized capacitor. Okay, I'm going to put that here, and I'm going to get another capacitor. All right, unpolarized capacitor. Put that there. All right, now I'm going to use the selector again, and I'm just going to type R for resistor. Okay, and there's our resistor. Okay, back over to the symbol picker here. I'm going to type LED. Now, there's a variety of different kinds of LEDs that you can pick, but we're just going with the standard LED to keep it simple for now. Okay, and you'll notice that that LED is sort of oriented horizontally. I want it to be vertical, so I'm just going to press the R button for rotate and drop it right there. All right, at this point, I want to expand on this a little bit, so I'm just scrolling up with the mouse, give us a little more room. Okay. All right, the other components that we're going to need are some headers for the input and the output. And back to the spreadsheet here. Those are going to be connectors. So we're gonna look for a con a 1 row by 2 pin header. So let's go ahead and get those, and then we're also going to get the test points. Test point 2 pole. All right, back over here, I'm going to go to the picker, and I'm going to type con. Okay, and we want the here it is, the 1 row by 2 pin header, and you can see what it looks like over here. It's just a very simple 2-pin header here. Okay, open. Let's say okay. We're going to drop that over here. That's going to be our input. We're going to grab another one of those, and let's see, con 1x2 pin. Here it is. Okay. And I'm going to put that on this side. Now, you'll notice that if you look carefully at that, you'll see that it has two little holes. Those are the connect points, and they're on the right, and I want those on the left. So I'm just going to rotate this twice, once, twice, and you'll see why I've done that. It's because these little hollow circles here are the connection points for wires. Okay, the other thing we're going to need is our switch, and we're going to need our test points. So to get the test points back to our spreadsheet, it's called test point two pole. So I'm back to the picker. Test, test point. Okay, test point two pole. And we actually need three of these. One for the input voltage, one for the output voltage, and one for measuring the current drawn by the device. So there's one here. I'm going to rotate that and put that right there. And we'll use that to measure the input voltage. Okay, I'm going to grab another one. And let's see. Sometimes after picking something, when I go back to the picker, sometimes it stays on the same point, the same item, and sometimes it has moved. Don't know why. But here it is. We'll grab this again. Okay, I'm going to rotate this. Okay, and I need one more of those for measuring current. Test point two pole. And I'm going to just put that right here for right now. Okay, we have everything except for our switch. Now, the switch that we have used, has selected for this design, is one, and I talked about in class how Colin Del Senior created a clever way of using a single pole double throw switch. In one position, it turns the device on, and in the other position, it allows us to measure the current drawn by the device. And it turns out that a double pole double throw switch is more commonly available than a single pole double throw. And so that's the switch you have in your kit. What we have is created a link here where we have the needed folders for those. So I'm going to click on that. And there are these four different items that'll show up. There are two of them that are needed, underscore mod and underscore sim. But I'm just going to ask you to download all of it. So I'm just going to let's see, download all four of these. And now what we're going to do is take this, it's currently in my download folder, and I'm going to put it into the project folder for KiCad. So I'm going to open up Finder, downloads, and here it is. And I want to copy this. And now I'm going to go to the folder that has our KiCad file, or our KiCad project. Okay, projects. Okay, 2025 304 projects. It's the 7805 demo. All right, and I'm just going to paste that here. Okay, so in this is the project folder that was created when we launched the project, and these are the three different files that we noted. KiCad.pro is the overall project file that contains everything and all the coordination and linking between these documents. There's the PCB file, and then there's the schematic capture file. This is a backup that gets created. And then in here, you'll see there are these four files that we just copied. And I'll show you what we're going to do with those. So I'm going to get out of this. This device that we're working with now has letters SLW. That's the symbol for that switch. Okay. And cancel that. All right, what I need to do is I need to add the symbol for that switch that we just downloaded into our library. our symbol library. So while we're working with this schematic error, the schematic editor, I'm going up to Preferences, Manage Symbol Libraries. Okay. And I'm going to put into my global library, I'm going to add a new symbol. So down here under Folder, I'm going to go and open up this here. Let's see, show these as icons. I'm going to go into here, into here, and I'm just going to notice that the only one of the four is highlighted. That's going to be our symbol for the switch. We're going to have to bring two things into our libraries. First, the symbol, and later on, the footprint. So we open that up. What is all this? Library already exists. Well, that's because um, I have already added it to my library. So I'm just going to skip this, but you won't. You'll be adding it in. Okay. So, okay. Error, blah, blah, blah. Let's see. Maybe I just cancel that. Okay. I'm going to go. And again, when we call this up, let's see. I'm going to close that. It's going to be SLW and then a bunch of numbers. So over to the symbol picker here on the right, I'm going to write SLW, and here it is down here. No symbol selected. No symbol selected. Okay. Um, I said that I had previously downloaded it, but it doesn't seem like it has a symbol here. So I'm going to go back to Preferences, and I'm going to actually load that again. Um, let's see. I'm going to add that in. It already exists, but I'm going to add it anyway. Hopefully, I won't have a problem with this. Okay. I guess what I'm going to do is I'm going to take this previous one out, away if I can. I'm going to put that in the trash. All right. Maybe it'll work for me this time. Okay. All right. There's some problem with a library that I'm not even using called MCU. I don't know what that's about. But it looks like we were successful in loading it because now when I am back to the picker, I type SLW, this comes up, and we see our single pole double throw switch. So finally, I can take that and add it in here. Okay, and so we're going to have to do one more addition of an item to the library later on, and we'll do that when we're building the PCB itself. So now what we're going to do is just complete this schematic, and we're going to do that by first wiring everything up. Okay. And so over here on this selection bar, we're going to choose this line here, not the thick line that says add a bus, but this line here that says add a wire. And I'm just going to click on that dot, and I'm bringing up a wire, clicking it here. Whoops. Okay, maybe I'll make this a little bit bigger for us. All right, this is tricky until you get the hang of it. Click, click. All right. I'm going to go from this output to the input of the op amp. Um, from the output, not the op amp, the 7805. Okay, from the output there, I'm going to come down to our output connector. Now I'm going to build the other half, the ground. It's going to be down here. Take a click and take a turn, and then come up and then connect that here. All right, so you can see our circuit is kind of starting to be formed. Let's see, I have to connect this test point here. All right. Um, okay, something that's a little tricky was the switch. Now recall that in one position, we're just connecting the input over to the input of the, well, that is our voltage input, we're connecting to the input of our 7805. In the other position, we're using that as our way to measure current. So I'm just going to connect that down here to this test point, and then bring that back up. So you see that if the switch is connecting pin 2 to pin 1, then we're directly connecting the input to the 7805. If we throw the switch into position 3, then it goes through this test point, which amounts to an open circuit, and we can put our current meter on there, close the circuit with the meter, and use that to measure current. Okay, we have our capacitor here, another capacitor lead down here. We have our ground, and we have another cap here, another cap here. We have our resistor. Now, this is a relatively simple circuit, um, but it's a nice one to start with. And let's see, we have our final test points. Okay, we're really finished with the wiring, but I do want to clean some things up here. So I'm going to go back. I'm still on the wiring device. I'm just going to go back here to this arrow. So now I just have a cursor. And what I want to do is change this. I'm going to click on this label here. I guess I'll double click on that. And instead of calling it, giving it the default name connector pin, I'm going to call it V in. Okay, so that's going to be J1 refers to our connector number one. J is a symbol for connector. All right, that's V in. Down here, I'm going to double click on this. And we're just changing the name of these labels here. We're going to call that V in test. Okay, this one here, I'm going to move it down here, this label, double click, and I'm going to call that I test. Okay. Um, C1, I'm going to call that 0.1 microfarad. This one I'm going to call 0.22 microfarad. And for this, refer back to the schematic from the last class or the last presentation on this. Okay, and we're going to use a 10K resistor, and that will give us a sort of a dim glow, but at a fairly low current. Now, I should add that the things that we're putting on here are really just labels for us. And that's why we're putting all this on here. All these labels will be transferred over to the printed circuit board as silkscreen later on. Okay, this test point here, I want to move it. I might even rotate it. Okay, and I'm going to call that 5V test. Okay, and looks like I have an extraneous or something happened to my wires here. I'm gonna delete that and delete that, and then we'll repair that. I'm gonna move TP2 over, just kind of get it out of the way. 5-volt test label, I'm putting that here. Okay, this one here, I'm gonna call that 5V out. All right, we're just missing a wire over here. So I'm gonna go back to the wire connect tool, down, and then over. Okay. I think we're in good shape. We may want to try to clean this up a little bit by, moving, let's say something, whoops, I'm back to the wire tool, escape. Um, Sometimes you can spend time kind of cleaning up a circuit. You can move things up or down if you want. Um, I'd say at this point, I'm not going to spend a lot of time trying to clean this up, but I'll just sort of show you how you do it. I could click on this, and if I wanted to move it up, you can see how it brings it up to the level of that one there. And I could do this with all of these if I wanted to. I could make that top line straight. Let's see if I can get away with that without making a mess. Cancel that. Okay. So we've done that. It's kind of straight. I think the next thing I'm going to do is just draw a box around this. Okay. Whoops. Let's see. Box. All right. That's just a decorative box. And I'm going to add a label um, with text here. And I'm just going to write 7805. Whoops. 7805 voltage regulator circuit for ECE 304 spring 2025. And you'll see where that we'll put that label right here. Okay. So there's our schematic. Um, and before we can claim we're finished with it, we do have to run uh, I'm going to go up to inspect here and I'm going to run electrical rules checker. I'm going to run it and we'll see if it has any problem. No problems. Okay. And let me go ahead and do it again where we actually create a problem. Suppose I were to delete this little wire here. Okay. Now I'll rerun the electrical rules checker, and we would want it to pick up on that problem. It didn't. Okay. What did it do is it left a little arrow here for us to look at. Um, it's this is similar to when you're debugging code and you try to compile and you see a lot of errors. You sort of look at the very first one and fix that, and then oftentimes that will take care of subsequent things. Um, okay, one thing I want to do here is I want to add a ground symbol, and it'll become clear later on when we're building the PCB why I want to do a ground. So I'm just going to go over here where it says ground. I'm going to type ground. I'm going to grab a ground symbol, and I'm just going to put it right here. I'm just labeling that node as being ground. Okay. All right, let's run the electrical rule spec check again. Okay, close. Um, okay, what it has done, it has left some arrows here and here. Um, and this would be important if we were going to be running a simulation using, let's see, back to the inspector. If we wanted to use Spice to actually run a simulation of the circuit, those would be important. But they're not important for us right now. Okay, there's our complete design. Let's go ahead and see if we can create a PCB of this. Let's see how that looks. Maybe I'll open that up in the PDF here. Come on, let's just go back and put that in our demo file. Okay, and this would be schematic. See what this is going to look like. Did it do it? ICAD projects. Okay, schematic PDF. Okay, so there it is. So that's we could get that, we could print it out, but this is the schematic that we've just um, captured. Now, what's important here is the identification of all the components and all their interconnections. That's what those are called nets, and that's really what matters here in terms of making our printed circuit board for this. So I'm going to close this out, and the next thing we're going to do is go and take this and build our printed circuit board. So I'm going to go up to this menu here. This is the PCB menu. That it'll open up that one. And you can see I have up at the top menu bar here. Um, well, let's just notice that this sort of tan one is our schematic editor. The green one was the PCB editor, and here's one that shows an arrow between the tan one and the green one. That's going to pull the components from the PCB from the schematic into the PCB editor. All right, and here it is all up here. Actually, I only have one component that came in, interestingly. Let's go back. Oh, you know what we did? We neglected to assign footprints. That's the problem. So we just skipped a step. I have to go back to um, so what happened is we pulled all the components from the schematic editor into the PCB editor, and only one component showed up, and that happens to be our 7805. The other components didn't show up, and that's because we left out an important step. We have the schematic designed like this, but what we have to do now is pick the footprints for all of our components. And so that's going to be this symbol up here, where you see we're sort of going from this our component picker symbol here to a symbol that looks like a chip, an integrated circuit chip. And we have to assign footprints to all the components. And so this is another key step. It's a detail kind of step, but let's start out with the capacitors. I'm going to call up that spreadsheet again, and this will tell us what components to use for our what footprints to use. So starting with the capacitors, um, there are two. There's going to be a menu on the left, and then a picker on the right. And so we're going to use the capacitor underscore THT. That's through hole technology. That's the way we're soldering is through hole as opposed to surface mount. So we'll see on the left of this footprint picker. We're going to dial down to capacitor THT, and then we want the disc capacitor with a diameter of 5.1 millimeter, width of 3.2, pitch of 5. Those refer to the physical diameter, width, and then the pitch is the spacing between the leads. Okay, so I'm going to go back here. It's capacitor THT, and then I'm going to, right, that's capacitor THT, and then just to show you that spreadsheet again, I've made that bold. Capacitor THT. That's the menu on the left. And then on the right, we're going to pick this one here, disk. Okay, so on the left, capacitor THT. And then we have all these options for capacitors. I'm scrolling down. Radial capacitors, axial capacitors. We wanted the disk. And it's this one here. 5.1 millimeters diameter, 3.2 millimeters width with a pitch of 5. I'm going to double check that. 5.1, 3.2, and 5. Yeah. Okay. I'm going to highlight capacitor back to this one, and I'm just going to double click on that. Okay. And we're going to do the same thing for the next capacitor. Copy and paste. Now, if we want to see what this looks like, I can do a right click and I can view that footprint. And this is all, I'll go to the 3D view. This is all it is. All we've just done there is we've specified a footprint for the capacitor. The capacitor just has two leads. So the body of the capacitor will sit above the board. And what's important is that we have these two copper pads that will be on our PCB, that they have drill holes. So the capacitor will just fit very neatly right into those two holes. The white box and this other stuff That is silkscreen. That's just documentation that we'll leave there that tells us to put this capacitor in there. Okay, so all these footprints are really just going to look like this. It's just going to be the drill holes and the copper pads for soldering, and then a little bit of documentation. Okay, we've done the capacitor. Okay, the LED. I'm just going to go over here on the left, and I'm going to look for LED, through hole LED, and we just want a 5 millimeter diameter LED. Okay, double click. Okay, there it is. Um, okay, let's get another easy one here. Resistor. I'm going to go down the bottom until I get a resistor here. Resistor through hole. Um, okay, back to our spreadsheet. The resistor is these are all of the different size parameters. What's important is this resistor has a length of 6.3 millimeters, a diameter of 2.5 millimeters, and then a pitch of 2.54. This is a vertically oriented resistor, and so you can orient these vertically or horizontally. Vertically, of course, takes up less horizontal space on the board. So this is what we're going to look for. This axial DIN0207. Okay, 0207. And I believe this is it. 6.3, 2.5, 2.54. I'm going to go back to this. It's 6.3, 2.5, 2.54 vertical. Okay, I want to make sure I've got the resistor here highlighted and double click. And let's just see what that looks like. Okay, this is just a couple of holes. That's all it is. And what we're going to do is we're going to take the resistor and we're going to bend the top lead over the body of it. So we'll orient it vertically and then solder it into those two through those holes and then solder onto the pads. And the pads are going to be on both the top and the bottom of the board. So you can see this is very detailed work to pick all these different components. Um, okay, we're going to have some connectors, V in and 5 volts out, and back to the spreadsheet. Now, in this design, I have pre-selected all of these symbols and all of these footprints for you. If you're doing a design from scratch, you'll have to actually spend some time choosing all the components, and then based on the physical size for those components, you're going to have to go and figure out what footprints to use. But let's go and get our connectors here for input and output. So on the left library, it's going to say connector pin header 2.54. 2.54 millimeters is that's a narrow spacing. That's a tenth of an inch. So these are going to be two little holes on the board that are just a tenth of an inch apart. Okay, and let's go find those. Connector pin header 2.54. And we just want 1x2. Here it is. 1x2, pitch of 2.54 vertical. And that's going to be here. And I'm going to copy that. Paste. Okay. Um, okay. Now we're going to have um, our switch. We may or may not already have the footprint. I may or may not already have the footprint loaded in. We're going to have to, just as we had to load in from that file I provided, we had to load in the symbol for the switch. You'll have to load in the footprint for the switch, and I'll show you how to do that. Okay, we have test points here. The last three things on here are going to be test points. Back to our spreadsheet. We just want test points two pads with a pitch of 5.08. 5.08 is 2/10 of an inch. And so we're just keeping that a little bit wider so we'll have room to get our probes on there, our multimeter probes for making tests later on. So this is what we want to get right now. Test points, 5.08 millimeter. So down, scroll down until we find test points. Test point. Okay. Through hole pad. Let's see. I'm going to go back to the spreadsheet again. It's test point, two pads, pitch 5.08. Let's see. Test point, two pads. Here it is, right up at the top. Two pads, pitch 5.08. So I'm going to double click, and then I'm going to copy that, paste. Now this is quite tedious work to get all this right. But that's because we're really preparing a design that's going to go off to be manufactured. Um, let's see. I'm going to go back and make sure we completed all of those. I think they're all going to be complete except for our switch. I'm just going to apply, save the schematic, and continue. And now we're going to go back to our uh, PCB editor, and I'm going to update that. Right, you see all these were now added in because we provided footprints for them. Okay. And here we have, and this is called the rat's nest. It's just all of our components, and they're all just sort of connected together based on all of the wiring that we just did. And what I'm going to do with that is I'm going to stop this video, and then I'm going to restart it as a second one with this as the starting point. So leave that there. I'm going to save this, and I'm going to stop the share, stop the recording.